yesterday. So you might already be given the quantities. So yesterday we had to determine what the quantities were and then set them to 0. Today you are already given the quantities. So the next step would be 2x plus 3 equals 0, x minus 4 equals 0. And so then you just solve for x, right? So we would subtract 3 from both sides. And you can have a fraction as your x-intercept. Okay, we just have 2 more examples. They're kind of intense, I'm not going to lie. I'm not going to pretend. Is anybody still working on number 3 and plotting the negative 3/2 and the 4? Okay. All right. There's one more blank piece of paper here. So this one's a little bit different because we can find a greatest common factor first. What would the greatest common factor be of that? 5x. 5x. Excellent. So I'm going to take the 5x out here, and I'm going to get x squared minus 6x plus 8. That looks a little bit nicer. And I'm going to ignore the 5x for a bit. I'll come back to that. And so now we're just going to focus on this quantity. No pressure, Brayden, but I'm hoping you get this pretty quick. Yep. -4, -2, -4, -2. So we have x minus 4 times x minus 2. Bring down the 5x. This is where it gets a little weird. We now have 3 zeros, or 3 roots, right? So how can you have 3 roots for a parabola, right? That doesn't seem normal. If I was to graph this, again, we don't know the vertex values, but we can maybe assume that it goes something like this, right? Or it's not just a parabola, it's actually, well, it's just how you would graph a quadratic, so it's like, it's real cool. Right, and of course these ordered pairs are all right, you know what, we're just not going to do the last example. I think you guys get it. So this will be the end of those notes, and I will be around with your spirals in just a second.